Give me the green screen.
Give me 3 seconds. Okay, you're live.
Welcome everyone to the DC Speaker Series. We're very excited to have an exciting talk for you today, whether you're streaming in on the Zoom or live on YouTube. Today we have Dr. Andrew Head from the University of Berkeley. Andrew studies how humans and algorithms can work together to perform creative tasks. His focus is on designing tools that can help experts share their knowledge, including scientists and programmers. He's currently a postdoctoral researcher at UC Berkeley, using tools like novel interfaces and artificial intelligence to support scholarly communication. His work has been supported by the Sloan Foundation, Allen Institute of AI, and ND-SEG Fellowship and internships with Google and Microsoft Research. He's received numerous awards, including one Chi Best Paper Award in 2019 and 2 honorable mention Best Paper Awards in 2020 and 2018. And one of his projects, Gather, has been turned into an extension for the popular VS Code programming editor by the VS Code Python team. And to date, that extension has been installed by programmers more than 3,000 times. So it's a great pleasure to welcome Andrew. And Andrew today is going to talk about how to transform creative coding messes into sample programs. So we're really excited about this talk. Take it away, Andrew.
Thanks so much for the kind introduction, Seren. And it's really a privilege to be a part of the Digital Culture Speaker Series today. So I'm going to be presenting a talk called Tools for Transforming Creative Coding Messes into Sample Programs. And fundamental to this talk is the belief that the code editors that we use every day are creativity support tools. And they should be able to help us turn our existing programs into more beautiful versions of those programs. And by beautiful, do I mean like just taking out comments from them and removing unwanted code? Well, it's kind of like that, but it's also a lot more. So let me give you an example. Let's say you're collaborating with my fabulous host, Dr. J. And Dr. J sends you a message saying, do you still have that graphics code that renders text and then expands that text until it fades out? I'm working on a project where I could really use that code. Cheers, Dr. J. In this case, you remember, yes, in fact, you do have code that renders text and expands it until it fades out, because several years ago, you had made a screensaver for your sister for her birthday that described how she can fly and put her face on a little fairy that bobbed up and down. And part of this was text that expanded out from the center point and gradually faded out. Now, the code that does this is this snippet that you can see on the screen right here. And you don't have to understand this code in order to kind of get the point here. I'll point you to some of the most relevant parts of this code snippet. There's this line right here that computes the size of the font. There's this line over here that computes the transparency of the font, gradually fading it out as the text remains on the screen longer. And then there are these lines down here that draw the text to the screen. And the issue is that this snippet that you want to share with Dr. J is tangled into this larger program. And you can't just copy and paste it with Dr. J because this part that you want to reuse has these structural dependencies on the other parts of the code. These are the class declarations, the method declarations that have to appear for the compiler to not error out when it's trying to run the code. And then there are also logical dependencies. These are the other lines of code that initialize the variables and logic in order for this snippet to run. And part of producing this code for Dr. J is also going to be removing certain parts of complexity that Dr. J doesn't care about. For instance, this list of colors that the text cycles through each time that it's rendered, Dr. J is not going to care about that. So that's something I'll want to simplify out. Which brings me to code beautification motivation number 1. Could your code editor help you extract reusable snippets from a tangled program? Let me give you another example. Let's say you're researching with Dr. J and he says, I'm running the analysis on the data we collected about flowers. And then he shares a foreboding statement. Though it seems like some of the code is missing. Can you help me get the code running again? Best, Dr. J. And you remember that you had been doing data analysis with code on a data set about flowers in a computational notebook. And throughout this process, you incrementally executed code in this computational notebook, running code just a few lines at a time. Because the computational notebook lets you do this, you included outputs in line with the code that you were running. For instance, printing the dimensionality and descriptive statistics about the data set, maybe even plotting the data set in order to see what it looks like, the different dimensions of this flower data set. Incrementally, you had changed the code to try out different ways of analyzing this data. For instance, trying to cluster the flowers based on different properties and then rerunning and regenerating this chart each time. And once again, because the programming environment lets you, you moved some of these cells around in order to put some of the code that you cared about the most up towards the top. The challenge is that this causes a colossal mess. When a week passes and Dr. J reaches out to you, and all of a sudden you have these questions such as, how did I produce this result? And given this particular medium that the code is shared within, there is no reasonable way of sussing out which lines of code were actually responsible for producing the results that are visible within this notebook. You might also ask the question, didn't I have a better version of this that I can share with Dr. J? And say I want to clean up this notebook, what can I get rid of? This brings us to beautification motivation number 2. Could your code editor help you untangle messy code like this? Okay, I'll give you one more example of what I mean by making code more beautiful with the assistance of an interactive code editor. Let's say you're a teaching assistant in Dr. J's class, and he asks, tomorrow we'll be teaching the class on how to program games using the processing framework. Could you put together a tutorial on game making? Dr. J remembers that you had previously worked with a processing framework in order to make a simple Mario-like game. And he's hoping that you'll make a tutorial kind of like the one that you see on the left hand of the screen, which is Mike Cameraman's Let's Make a Mario Game tutorial. And it's going to have a few components to it. It's going to have written instructions that describe how to assemble together a bunch of snippets into a program. It's going to have these nicely formatted snippets, which showcase just a few lines of code at a time that eventually need to get assembled together into this larger program. And there will also be the outputs of running the program so that the students, when they're following along with it, can check their work. If you're really feeling ambitious, maybe you'll even have these interactive outputs like the one in this Mario tutorial. You can actually play along with the game. The challenge is, in order to produce a tutorial like this, which has dozens of snippets and outputs, you have to once again start from a source program and then transform it, selecting code of interest, simplifying that code to make it easier to read and understand, sequencing it by splitting it into a number of different snippets, and then supplementing it with descriptive text that describes what those snippets are doing, and these outputs all along the way that help someone check their work. And one of the challenges in this process is that it's going to be iterative, because inevitably, once you see this tutorial finished, you're going to want to go back and change some of the code in order to make it more readable. And then you'll also want to change all of the outputs that are based on it. This brings us to our final beautification motivation. Could your code editor help you turn a program into a tutorial? In this talk, I introduce this idea of a type of tool, which I call a distillation tool, which helps someone distill an existing program into a sample program. By sample program, I mean these snippets, these tutorials, these cleaned up versions of someone's original program that are meant to be reused and read by others. A distillation tool provides interactivity to a programmer in order to help them transform their existing programs into sample programs. And while I'll be talking mostly about distillation in the context of augmenting code editors today, the thing that really gets me going about thinking about distillation tools is thinking about what it could mean beyond the programming environment. So let's say you're working on a physical prototyping project, and what if your creativity support tool of the breadboard could help you clean up that breadboard so it had no wire crossings to make it easier to debug by yourself and your TA. Another example that's close to my heart as a musician is, what if you could take something like a symphony for an orchestra, and a tool like Sibelius or Finale could help you distill this down into a simpler version, like four-part harmonies for a string quartet. Or, for those of us in the room who read research papers, what if you could distill down a research paper to a more accessible version of of that document like a blog post that made some of the insights more readily available to readers. The essence of a distillation tool is it provides an interactive loop between an author and the tool in order to transform something existing into a more beautiful version of that thing. And the reason that we focus on code editors in particular is because of the secret sauce that we can put in them, specifically program analysis. There's a rich suite of existing techniques for understanding facts about programs and what they're doing while they're running that we can leverage in order to help programmers simplify their code through a distillation tool. Over the course of the next 30 minutes, what I want to do is I want to answer 3 questions for you. First, I want to share some studies that we've run to provide some evidence into what makes it hard to distill code into sample programs. I'm going to share demos of 3 interactive systems that we built, prototypes that support the transformation of existing programs into snippets, tutorials, and cleaner versions of data analysis code. And then I also want to discuss the implementations of this, because when we think about the future of distillation tools, it depends on the tools being able to reason intelligent things about people's creative artifacts. And so what are those modes of reasoning for code? I'll discuss these 3 different questions through the exploration of 3 different tools. Code Scoop, which is a tool for extracting reusable snippets from existing programs. Tori, which is a tool for formatting programming tutorials out of existing source programs by helping someone split it into snippets and outputs and keep all of those snippets and outputs consistent with each other. And then finally, I'll talk about gathering tools, which is an extension to computational notebooks that helps data analysts be able to untangle these messes that come about through exploratory data analysis. Across these 3 tools, they support these core distillation needs of helping authors select, simplify, supplement, and sequence their code. Let's start by talking about Code Scoop. And we should start by talking about the question that I bet is on many of your minds, which is, why is this called Code Scoop? The reason is because let's pretend that this piece of code is delicious ice cream. What we wanted to do with Code Scoop was build a tool that made it as easy to extract a snippet as scooping ice cream out of this tub and serving it up as a tasty snippet for someone else to read and reuse. The task that Code Scoop was built to support was sharing snippets that were based on existing programs. And if you put yourself back in your shoes of this collaborator of Dr. J, who's trying to share this piece of code that renders and expands this text from this wacky screensaver, you'll recall that the challenge is that you're starting with this detailed personal code, and from this you want to share a concise, self-contained snippet that Dr. J can readily run and easily extend. The challenge being, of course, that in order to reuse this piece of code, you also need to include structural dependencies and logical dependencies, or remove some of those dependencies. Following a human-computer interaction research-based approach, we started out on this project by just trying to collect more evidence about the challenges of distillation. So we observed 12 programmers as they created snippets from their own programs. And we observed several challenges to this process of distillation. One of them was that the workspaces in which programmers were doing distillation could just be a complicated mess. So for instance, here is a visually simplified version of one of the programmers' workspaces. And one of the things that you might notice right off the bat is that there are many windows open serving many different purposes, suggesting that maybe there should just be an integrated tool that pulls some of these things together. In particular, this programmer had both a code editor open in which they were constructing a code snippet, and then they also had another program editor open with their original program, and they were continually copying code from their existing editor into their sample code editor, and then they were running it in the third editor at the very bottom of the screen in order to execute it. This suggests that perhaps a distillation tool should be able to integrate many of these different tools and their functionalities into a place where someone's attention might be less split. Throughout the process of distillation, we saw several indications that the process was just error prone. as programmers copied code from their existing program into their snippet, they often made transcription errors. Sometimes they forgot code. And if they instead took the tack of starting at a big source program and slowly removing lines of code from it, this could be time consuming as well. We also observed that when programmers were making edits to their code, they introduced errors in the process of trying to simplify it, which led us to the hypotheses that tools could help out with the distillation process in two ways. First, by helping programmers select subsets of code quickly and completely from these existing programs. And second, by helping them simplify the program without introducing errors. So let me show you the tool that we designed to help with this process of extracting snippets from existing programs. This is a code editor that's been augmented with CodeScoop. And there's a bunch of code here. Once again, you only really have to pay attention to a couple of lines of it. Specifically, let's say you want to share a snippet that shows to someone how to use a database library. And the two steps that you want to share are where a row of data is fetched from a database on this line, and this other line that extracts from that row the data for a book and saves it to a new variable. And then, of course, above this code, there's going to be a suite of logical and structural dependencies that these two lines depend on. And CodeScoop is going to help you pull that out into a short example program. So the main interaction mechanism with CodeScoop is to work through an iterative sequence of these small interactive decisions that helps you slowly build up this example. The place that you start is picking code of interest from the program and then clicking the scoop button. What you'll notice at this point is that the editor splits into two panes, where on the left pane you can see the original source program, and on the right one you can see an example that you're going to build up. In this way, CodeScoop integrates together these two editors into one place so that you no longer have to split your attention across multiple applications. CodeScoop then guides you through the process of expanding out this example into a complete example. And it does this by flagging things that need to be resolved in the example in order for it to run. So CodeScoop here recognizes that cursor and column index title both have some type of logical dependency that is not yet resolved. And so CodeScoop will recommend fixes to this. For instance, I can hover over this cursor, and then I can hover over add code, and then CodeScoop shows me a line from the original code that can be included in this example in order to provide this logical dependency. It does this by applying static data flow analysis, which I'll talk about a little bit later, in order to assess which lines of code depend on which other lines of code. CodeScoop also finds structural dependencies. So once I add this line of code, what you'll see is then it finds a for loop, it finds a while loop, it finds an if structure, it finds a try block. And all of these are structural dependencies of the code that I'm running. And it helps me easily review those lines of code that I might be forgetting by highlighting where they are in the original program, allowing me to see them in context to decide whether or not they belong in the example. Here, most of these structural dependencies actually aren't necessary, so I'll leave them out for the sake of simplicity, but I'll include this try structure in order to show how error handling should work for this cursor.getScreen call. Next, CodeScoop will find other uses of the variables that are already included that might modify the meaning of those variables. For instance, these other uses of cursor that might initialize the cursor value. For instance, the call to execute and fetch one. And what CodeScoop is really doing here is that it's turning what would be a sequential scan through the original source program into a more random access version of that, where I can just review a whole bunch of potential inclusions in rapid succession. It also allows me to simplify the code by replacing variables with concrete values that they took on during the program execution. For instance, replacing this column variable with the actual column index. And I'll show you one more example here, where query can be replaced with the actual SQL query that was run against the database. In this way, I don't have to resolve logical dependencies by adding additional code to the example, but rather I can fix them up by just simplifying the code. And then I'm going to make one more fix. And with this final fix, you'll see a bunch of extra lines just got added to the very top, these import statements. CodeScoop added those automatically because there was only one reasonable decision to be made in order to fix up the example in order to be complete, which was to include those import statements. In that way, we've now just pulled out a complete code example that we can share with Dr. J that is going to run on his machine. Taking a look back on the interaction with CodeScoop, the interaction with CodeScoop is this iterative loop of the human making these micro decisions about what needs to be included in the example and what doesn't, which begins with these first selections of code, these incremental code fix-ups, these reviews of optional structural dependencies that should be included, as well as these variable substitutions that serve as a mechanism for being able to simplify the code. And just like a melting ice cream cone, all of these different steps of the scooping process flow together in such a way that a programmer makes a few decisions about each location in the code, bit by bit, on all of these fronts until they end up with a complete example. We gathered evidence of the usability of these tools by conducting an in-lab usability study with 19 undergraduate student programmers, having them create snippets from an existing program. And we observed that in comparison to a baseline text editor, they found it faster to use. And they also reported that it was easier to use, more enjoyable to use, and they were more satisfied with the sample programs that they produced with CodeScoop. What I find really interesting about the examples that participants produced with CodeScoop was the variation in the types of snippets that they produced, despite the fact that CodeScoop currently has a limited vocabulary of the types of resolutions that it allows within these snippets. So, for instance, maybe you're more like programmer one, who chose to address one of the experimental tasks by adding error checking into the example that they produced with exception handling and post conditions. Or maybe you're more like programmer two, who decided that this error handling logic wasn't so important, but what they really wanted to convey was some of the semantics of what the program was doing. And the way that they conveyed this was by including explicit variable declarations for each of the values that was used in the program, as well as showed some additional steps at the end of it of how the extracted data from the database would be used. This diversity of opinions about how these examples should be built out also differed at a very fine-grained level. So when you look at the individual variables that had to be resolved when someone was using CodeScoop, you can see that there was almost no variable in any of the tasks that two programmers didn't go a different way in terms of deciding whether it should be fixed by adding additional code to the example or by inserting a literal into its place, suggesting that these are decisions that are going to be up to the author and that CodeScoop already provides with its set of functionality. So now that we've talked a little bit about the interactive system of CodeScoop and some of the challenges of pulling snippets out of existing programs, I want to let you in on secret sauce. What are the implementation patterns that enable a tool like this to work? Within the software engineering literature, there's this technique called program slicing. And while the program slicer usually involves thousands of lines of code in order to implement, the basic idea behind it is very simple. A program slicer essentially lets you point to a line in a program, and then it finds all of the logical and structural dependencies for that code, and then pulls out a subset of the code from the original program with those dependencies. The real challenge here is that a program slicer isn't really enough for pulling out a reusable snippet, because as we saw before, as someone is producing these snippets, some of these logical and structural dependencies might not actually be necessary. And so what a program scooper does is it breaks apart this process of program slicing into a series of these small, digestible decisions that a programmer has to make, and lets you choose which lines to include in the face of ambiguity, which ones not to include, and in some cases, being able to swap out entire lines or sets of lines with simplifications like the literal value substitutions that you saw before. Let's talk about another distillation tool that's designed to support a different type of task, specifically the production of programming tutorials. Because what you're going to see here is that a different type of program analysis and a different type of interactions are totally appropriate for Tori than what was appropriate for CodeScoop. To set the stage again, Let's say you're this TA who's trying to produce a tutorial like this beautiful Let's Make a Mario Game tutorial. And the real challenge here is that you're starting with this long source program from which you're going to have to select code, simplify code, sequence it into snippets, supplement it with rich text descriptions and outputs in order to produce that tutorial. How can a tool help out with this process? Well, we wanted to gather a little bit more context about just what support was needed in the production of programming tutorials. So one place that we started was just looking at 200 programming tutorials that were scattered across the web for all kinds of different topics, from machine learning to game making to HTML, JavaScript web development, to just learning how to use a programming language. And we analyzed all kinds of different aspects of these tutorials in order to try to better understand what might a tutorial author have to do, what is the task ahead of them in terms of producing all of these snippets and outputs. And what we developed was this picture of programming tutorials, which have these complex structures and dependencies within them. So these logical dependencies and structural dependencies aren't unique to just like programs that are made up of just code. They're also common in these tutorials with all of these snippets. So one of the things that we observed is that first, almost all of the tutorials included code fragments that wouldn't be able to run on their own unless they were combined with other pieces of code. We also observed that the same code could be repeated multiple times in multiple snippets. Sometimes it appears exactly in the same way, and sometimes it's revised in later snippets. We also observed that most of these tutorials included outputs that were generated by running some of the code from the tutorial. Some of these were console outputs, some of these were images of outputs, and a small fraction of them even had live demos that someone could play around with within the tutorial. We also interviewed 12 accomplished authors of programming tutorials who had written anywhere between a few tutorials to hundreds of them. And one of the challenges that we learned about was this challenge of keeping everything consistent as someone is sequencing code. You can imagine as someone is taking code out of a source program and putting it into a tutorial, all of a sudden you have this clone of the code from the source program in the tutorial. And you might have this clone of code in one snippet in another snippet where it appears a second time. And then once again, there's this dependency of the output, which depends on the combinations of snippets that appears before it. There's this challenge of keeping things consistent when a tutorial author determines partway through the process of putting together one of these tutorials, they want to change something in the original source program, or they want to change something in one of these snippets, and all of a sudden they see the task ahead of them, which is to update all of these other snippets and outputs in their workspace. In order to support people who are trying to make programming tutorials, we built a tool which we called Tori. And the first thing that you'll notice in Tori is that it's a little bit reminiscent of the tool that you saw for CodeScoop, in that on the left-hand side, there is a source program, and on the right-hand side, there's a derived example program that an author is going to create. Tori provides several functionalities to make it easier to produce these programming tutorials. And the first one, which you can see on the screen, is just the ability to write rich descriptive text of what the code is doing. It also allows you to embed snippets in the tutorial. For instance, selecting this initialization of the rectangle object and including it as a snippet within the tutorial. The first thing that Tori does in order to help a tutorial author keep their workspace consistent is it establishes these links between the snippet and the source program. So when you go back to change something in the source program, it gets reflected in the snippets in the tutorial, and vice versa. You can change some of the code in the snippet and it gets reflected in the source program. And when you have many snippets within your tutorial, those links also propagate across the tutorial as well. Let's say you're writing this tutorial, then you're going to add a little bit more descriptive text. You add a declaration of the rectangle class, and then you add what's going to be the first output of this tutorial, which is a print statement which shows the width of the rectangle that's been initialized up above. So Tori not only allows you to embed these outputs into this rich text editor document, it also is really intelligent about how it produces these outputs. Specifically, what you'll observe if you see this tutorial is that the code, as it's listed in the tutorial, if it were to just be run by a conventional interpreter, wouldn't run correctly because you can see there's this use of this rectangle class before it's declared in the second snippet. In other words, this is logically invalid code in the way that it's currently ordered here. But Tori, as a smarter tool for being able to create these tutorials, keeps track of where all of these snippets are coming from within the source program. And so what it does in order to generate and update these outputs is it puts these snippets back in their source program order and then runs them in the background and then embeds the output of running them within the tutorial. What this means is that then you can go back and you can change some of the code in these snippets, and then those outputs are going to update live, which might save you a lot of time once you have a dozen or 2 dozen of these outputs within the tutorial. Tori will provide you with additional flexibility in how you break this code apart into snippets. For instance, code can be repeated in multiple snippets. It can also be fragmented in ways that you wouldn't actually be capable of running through an interpreter or compiling with a compiler. In this case, you can pull out this method for area and include it in its own snippet, even though it appears outside of the structural dependence of the class that it appears in. And because Tori, once again, keeps track of how all of these snippets, where all these snippets come from and how they should fit together, Tori can continue to keep all of the outputs consistent with the snippets that appear above it. Altogether, this together with another feature of being able to hide arbitrary snippets so that they can be included in the execution and production of the outputs without appearing to the reader. Altogether, this is the suite of features that Tori provides in order to help a programmer be able to sequence and supplement their code in order to make it into a rich narrative to teach someone else. We invited 12 tutorial authors to the lab and asked them to create tutorials using Tori. And what we observed is that even with only 20 or 30 minutes of training and about 20 or 30 minutes of time in order to create these tutorials, they were already starting to use some of Tori's features for being able to create flexibly organized tutorials. For instance, repeating code across multiple snippets, showing code out of the order that it would have to execute by an interpreter in order to be valid, and fragmenting code into these little blocks, for instance, splitting up the declaration and implementation of a class or method, because that's the way that they thought that the code should really be shown. To give you an example of this, this is one of the tutorials produced by one of the participants, where you can see code fragments. You can see code that's shown second time, where the second time it's embellished. You can see a piece of code that was hidden so that it will affect the computation of the outputs, but not be shown to the reader. And then you can see these generated outputs that were updated live. So once again, what is the secret sauce that enables this? The secret sauce that supports Tori is this ability to understand where all of these snippets are coming from and how they should be put together in order to produce the outputs. As someone copies code from the source program into the tutorial, it builds this implicit link in the backend that's going to be used to propagate edits across both directions. And in order to produce these outputs, because Tori remembers where all of these snippets came from in the source program, it's capable of running in the backend these snippets in order to produce and embed these outputs. We'll conclude by talking about a third prototype project called Gathering Tools, which is designed to help data analysts untangle and clean up their data analysis code in computational notebooks. The scenario that Code Gathering Tools was built to support is this one that we talked about before, where Dr. J emails you and says, I'm rerunning the analysis and it seems like some of the code is missing. And you're panicked because a week has passed and you have these critical questions of, how did I produce this chart? Didn't I have a better version of this chart? And what code can I get rid of if I'm going to clean up this notebook and share it with someone else? Code Gathering Tools answers all of these questions by helping a programmer transform their code. So let's say you have the question, how did I produce this result? What you'll see when you're working in an environment with Code Gathering Tools enabled is first, all of the results are highlighted in blue. This is all of the variable definitions and all of the outputs, like the chart that's been produced. This means any of these things are interactive, and you can gather the code that produced any of them. In order to do this, what you'll do is you'll click on the result, And what you'll see at this point is that some of the code in the notebook has just been highlighted in purple. These are the lines of code that were used to compute that result. And then you can click on Gather to Notebook in the toolbar. When you click this button, you're given this notebook, which consists of the reduced, ordered, and complete cells that can be used in order to replicate this result. And just to prove to you that it can indeed replicate the result, if I run this code again, you see you get the same chart. So this is how we answer the question, how did I produce this? If you have the question, didn't I have a better version of this result? You can once again click on the result of interest and then click on Gather to Revisions. And what opens up is a version browser, where the first thing that you'll notice is at the bottom of the version browser is all of the different versions of the result that was produced shown side by side so that you can compare them. And then there's the ordered, reduced subset of cells that produce that result, which are once again shown side by side, with cell level diffs automatically highlighted so that you can tell what was different about the code to produce this version of the result versus another version of the result. And you can scroll horizontally in order to see all prior versions of that result, opening any of them up in a new notebook or copying the code that produced them to the clipboard so that you can use it elsewhere. The third question is, what can I get rid of? And just using features that you've already seen before, you can click on a result. The lines that are relevant are highlighted in purple. All of the other lines that weren't used to produce this result are not highlighted. And so those are prime candidates for removing when you clean up the notebook. We found that of the tools that we've explored so far, and the code gathering tools really strikes a chord with programmers. When we had data analysts use code gathering tools, and we asked them to use it while they were working on an exploratory data analysis task, we found that participants consistently rated gathering to a notebook as very useful, and the ability to highlight these dependencies within a notebook is at least somewhat useful. Participants described the feature of gathering to a notebook as beautiful and amazing, saying that it hits the nail on the head. And you can understand why when you see some of the purposes that they were starting to put code gathering tools to during the exploratory data analysis process. For instance, distilling their notebook as a finishing move where they pulled out the results of their analysis and the code that caused it at the very end of the analysis. They would gather their code for multiple audiences, for instance, producing a different version of a notebook for a supervisor than they would produce for a collaborator. They used it as a mechanism for lightweight branching, taking a checkpoint of the results in their notebook and then continuing on in their original notebook. And they also created personal references for themselves to continue to look back on as their analysis proceeded. The tool was useful enough that we built out a reference implementation of the tool called NDGather, which can be installed in the Jupyter Lab exploratory data analysis environment. And in fact, one of the really exciting things is that the Python team at VS Code, the popular programming editor of VS Code, has also implemented Gather as a capability in their notebooks tool for Python programmers. And to date, it has thousands of installations. So if you're curious on how Gather could fit in as a practical distillation tool into your everyday programming activity, you should check out that tool. Going back to this question of what does it take to actually build a distillation tool like this? Well, we come back to our friend, the program analysis called program slicing. And the challenge here is that program slicing can't really work on notebooks the way it did in CodeScoop. Because in notebooks, some of the code might be missing because you've overwritten it or deleted it. And the code might also appear out of the order that it actually needs to be in order to execute. So how do we slice a computational notebook? The way we do this is by preserving a parallel representation of the notebook, which is just the execution log of all of the code that's been executed within the notebook. And we cross-reference this against the original notebook, aligning cells in the execution log to where they appear in the notebook. So whenever someone clicks on a result in the notebook, we find that entry within the execution log and then perform a backward slice to find the structural and logical dependencies in the execution log. This yields program slices that with a little bit of formatting could be molded into these cleaned and ordered notebooks, as well as these listings of versioned results that can be viewed side by side with each other. So Those are the three tools for distilling programs. And as I mentioned, the main point of this talk is to give you a sense of what makes it hard to distill code into simple sample programs, to get a sense of what it would be like to work with an interactive distillation tool that allows you to change some complicated creative artifact you already have into something that's more ready to be reused and read by other people, and also implementation patterns for how you can build these tools. So let's take stock of this. A distillation tool in the domain of programming is an interactive tool that a programmer works with iteratively. The functionality that it provides is assistance in selecting code, simplifying that code, supplementing that code, and sequencing it into snippets. And the secret sauce that enables it is program analysis. And this program analysis doesn't just take one flavor, but rather the program analysis changes to adapt to the different types of distillation tasks. Because as we've seen, you might need program analyses that handle things like analyzing the structural and logical dependencies, that logs the values that variables take on over the course of program execution, that enables linked editing across multiple versions of the code, and records programming histories in order to make the results of exploration available to programmers long after they've forgotten about some of their exploration. And all of these together contribute to producing an efficient and flexible authoring experience for the programmer who wants to distill their programs. So the future outlook for distillation tools, I think, is exciting for two reasons. The first is within the domain of programming. I want there to be tools that help programmers distill explorable tutorials out of their existing programs. What do I mean by explorable tutorials? Well, this is an explorable tutorial from the React Native documentation. It allows someone to play around with it and see what changes to how changes to the code get reflected in changes to the output. For instance, by changing the border width and the border color and the size of this cat graphic. As you make any of these changes, the output automatically regenerates on the right-hand side. The tutorial authors that we've spoken to are highly enthusiastic about being able to port these to other types of tutorials. And users of tutorials also think that these features are super cool. But there's a lot of research work that has to go into figuring out whether or not these explorable tutorials are pedagogically useful, and also what types of additional implementation patterns are necessary in order to help programmers transform a static piece of code into something that can be tinkered with, like an explorable tutorial. So that's one direction which I think the future outlook is really interesting. The other direction is thinking about distillation tools beyond programming. For instance, having this breadboard that can help you clean it up in order to make it easier to debug, or extending something like Finale or Sibelius that has an interactive loop like CodeScoop that helps you pull out melody lines and harmonizations of interest as you try to turn it into a quartet. Or one of my favorites, which is the ability to take something like a research paper and turn it into a more accessible format to release some research insights to larger communities that might be interested in them. And while this seems like it might be a crazy idea, we're seeing these advances in machine learning and natural language processing these days that might someday be able to find these things like logical and structural dependencies within these natural language texts that could then be used as the foundations for being able to build out these interactive tools that allow someone to simplify the text and share it with an even larger audience. The abstract idea underlying all of these ideas is thinking about distillation as a creative task in its own right. This right here is a taxonomy of different creative activities from Ben Schneiderman's 2002 article on creativity support tools. Ben Schneiderman is a famous researcher in the field of information visualization and is really a thought leader in the creativity support tools literature. And two of these activities that he points out are exploring solutions and composing artifacts. And where distillation fits is really in the transitions between some of these tasks, taking explorations and turning them into new compositions. And also taking existing compositions and turning them into new compositions that are going to be easier for people to read and reuse and engage with. I think that distillation should be one of these 8 tasks, adding a 9th one to the list. And I think that Of course, across this talk, we start to get a glimpse of all of the different ways in which tools can support this transition from exploration to composition and between different stages of composition. This talk wouldn't be complete without recognizing my awesome mentors and collaborators at UC Berkeley, Microsoft Research, and Google, who've helped with many stages of this project, from ideation to recruiting users to designing studies and beyond. So thank you to all of them for helping us explore this exciting direction of research. And with that, I'd like to thank you for your attention and welcome any questions.
Great. Thanks, Andrew, for the really exciting talk. So to remind the audience, you can ask questions either in the chat of the Zoom or unmute for those of you who are on the Zoom. We'll also monitor the YouTube live chat if anyone has a question that they want to pose there. But maybe I'll kick it off with, I like this idea of the code scoop. What's interesting is, like, I think, like, you know, the code scoop is like you're scooping the best parts of the code, you know, it's the ice cream. But, you know, if I'm a professor, sometimes I want the vegetables, I want the unit test, I want, you know, is there like an associated vegetable scoop, or is that like not a fun part of distillation?
That's a great question. So you're right, code scoop. You know, the video that we showed the scooping of ice cream out of a big tub of ice cream, suggesting that what it pulls out might be very enticing but unhealthy for you. I really don't see a difference between what it would be like to scoop, let's say, a bunch of vegetables out of a bucket of vegetables. I think the same tool set would support would also support the scooping of the, I guess, more mundane aspects of the code out of it. So I guess, like, to provide an example, what's something that you might want to do that corresponds to vegetables? It could be something like wanting to pull out just some of the structure, like the skeleton of the code that shows someone, here's how you build a class in Java, for instance, which is like snore. It's like not particularly interesting, but like it's something that you have to show to someone for. And so in that case, you can still use code scoop. You just need to find the structural dependencies from the certain pieces of structure that someone points to within the Java class, maybe like the declaration of a method, and then you know that it depends on this class, and maybe that class has a super class in some other file. And as long as you help someone incrementally trace over those dependencies and are capable of finding those dependencies, the same code scoop interaction mechanism is designed to support all of those cases.
Great. We have Frankie Liu has a more general question. He says, thanks for the great talk. A pretty broad question. What is your outlook on the future of CS education? So clearly these tools have a strong focus in education. Kind of interested in hearing your perspective.
Yeah, absolutely. So I have two thoughts. I think, so CS education is scaling simultaneously in both formal and informal ways. The tools within this talk are focused more on the informal side of education, where you can imagine the snippets and programming tutorials that are created by authors using tools like these could help people post these tutorials to the web and create new types of books that you can buy, tutorials that you can search for on the web, in order to teach yourself on the fly outside of the classroom. That's one of the things that I found to be really invaluable to my growth as a programmer, finding these informal learning resources outside of the classroom. And so that's one of the reasons that this talk takes this approach. It's in order to empower informal knowledge sharing amongst programmers. And so I think the future for that is bright. I think that there's stronger communities of sharing tutorials online all the time. Kim, for instance, creates these awesome video tutorials of like processing. I'm sure there are many other people in the department who do this too. There's just tons of people interested in that. So I think things are only just going to get better and better in the informal sphere, especially as tools like the ones in this talk mature. On the other side of things, there's formal CS education, which I think one of the most exciting things happening in formal CS education, also a little bit scary, is due to great interest in CS education, enrollment in classes is just exploding. And so I have a parallel line of research that explores, for instance, how we can scale things like providing feedback at scale in computer science classrooms in order to help TAs be able to individualize instruction to students. I think that research has a long way to go, but it also takes advantage of some of these facts that you can learn a lot of things by looking at code and how it evolves over time. And maybe you can amplify a teacher's effort by having sophisticated ways of processing that code and connecting teachers and students in the right way. So I think the future there is maybe a little bit scary, but I also think that there's lots of reasons to be hopeful and lots of cool research that's going into improving CS education.
I think Byron has a question.
Yeah, hi Andrew. I'm sorry I joined the talk late, so you may have addressed this question already. But what I saw, I really enjoyed. I'm curious. Well, first of all, I want to comment on the notion of being able to distill these electronic circuits. I saw the Arduino board, and I think that would be incredible if we could, have some tools that enable that as well. But just on the software side of things, do you see a path for distilling multiple blocks of or multiple complete code bases into something that could then be recombined into something new?
Yes. So if I understand correctly, you're asking like, oftentimes we use these reusable components in order to build up new pieces of software. We find snippets on Stack Overflow. We use objects from the Java API. Yep. People distribute these libraries with super useful snippets in them. Could you build tools that help people basically make those types of libraries of components? Is that understanding you correctly?
Yeah, I mean, essentially, I mean, I guess, yeah, the good way of summarizing it is, could you take the best of what I see in this code and what this other code does, use that distillation as a method of basically stripping out everything that doesn't do those, and then in a fairly automated way recombining those, or what would be the limitations on that?
Yeah, totally. So in the program analysis literature, there's, I think, a couple of cool inklings of this idea. And I think the first step is just pulling out these reusable patterns. And then the second step is building up software from those patterns. When you extract, in order to extract these maybe generalized patterns from existing code, one of the things that you might be able to do is look what combinations of code are statistically most likely across huge sets of code bases of interest. And then maybe you can even help an author pull out, like, it looks like people are going to use code in this way an awful lot of the time. And it looks like they're going to need to catch these errors and orchestrate these components together. And there's already some examples of this research. For instance, Elena Glassman's work on visualizing API usages at scale that does some of this work of taking a statistical perspective at looking at many of these examples and trying to figure out what's most common about them. And I'd love to strap something like that into CodeScoop in order to be able to pull out some of these reusable patterns. And then there's the stage of being able to build up new software systems from them. And I think this is challenging. I think,
for sure.
because the general problem of program synthesis, of pulling together these various parts of software systems into a working system, is just generally a very formally difficult problem. That said, there's a lot of people who are exploring this nowadays. So for instance, there's this research problem called Synthesizing What I Mean, SWIM for short, that pulls together a bunch of snippets that it finds on Stack Overflow and tries to kind of graph them onto each other to fulfill new purposes. This is really challenging. But I guess probably somewhere in the middle is, you can imagine new types of code browsers maybe that allow people to say, well, I want code that does something kind of like this. Maybe they can sketch something. Maybe they can show example outputs from other programs. And then the tool can help them find other snippets of interest that they can then build together on their own. So I guess that's the way that I see, like, I think that's probably the near-term research horizon for those types of tools. And of course, like in the long run, it would be really cool to see something that could automatically compose some of these snippets together.
Yeah. So for now, the human remains in the loop.
The human is still very important.
Yeah. Thank you. That's great.
So,
Thanks, Byron.
Lauren Olson had a question, and I'm actually going to tack Robert's question on top of that. So Lauren Olson wanted to ask, how difficult is it to support different languages in these tools? Like, it seems like most of your examples were Python, at least from what you showed us, different languages. And Robert wanted to add on if you had any thoughts about how these tools could be repurposed for visual programming languages. You know, things like maybe Max MSP or other types of visual programming languages.
Yeah, totally. So let's start with Lauren's question, which is how easy are these to port to other languages? I guess how language independent are the tools? So out of the tools that I presented, 2 of them are very language dependent, and one of them is language independent. So CodeScoop and so the CodeScoop, the one for extracting snippets, and code gathering tools, the one for cleaning up computational notebooks, are programming language specific. And the main reason behind that is because they both rely on program splicers that can understand the logical and structural dependencies within a program. And in order to do that, you need a really good program analyzer that's capable of finding those dependencies across the different lines of code within the program. So presupposing the use of CodeScoop or code gathering tools on a new language, you would need a new version of that program analysis component. That said, the interactions would look very much the same, of these interactive loops of making these small kind of micro decisions in order to pull out a new program. Tori, on the other hand, is mostly language independent in that it doesn't have any of the slicing stuff in it. And across the different languages, you can share this logic of how it stacks together snippets in the right way in order to produce the outputs. All you really need for a given language is some way of telling Tori a command to run in order to execute a program that it synthesizes out of the snippets that appear within the tutorial. But otherwise, the rest of it remains the same. So that's Lauren's question. And then the other question was visual languages. And I think you can see that from my example of the breadboard that helps you clean it up, I think that when I think about the wiring crossings on a breadboard, I also think about some of these data flow crossings that appear in visual programming environments, say like Max MSP or LabVIEW. And so in those cases, yeah, I mean, it would be, we already have tools that can do things like, lay out circuit boards. Why couldn't you apply some of those techniques to cleaning up a LabVIEW dashboard or cleaning up a Max MSP environment? I guess then there's the question of like when you're doing super creative things in Max MSP, like creating these multimedia, rich visualizations and audio effects and stuff. Then I guess one of the questions is, can tools help people simplify some of the logic that they have in their Max MSP, in their Max MSP programs that make it easier for other people to tinker with and to expand upon? And I think that's a really interesting question, and it would probably involve pulling in certain new forms of audio analysis and visual analysis in order to figure out what ways you could replace complicated components with equivalent components. So I think that's a really interesting question, and I think there's some ways we could do it, support visual languages quickly, and some other ones that represent a very broad research horizon.
Great. Well, I think we're out of time, unfortunately, but this was a great talk. So wanted to thank those of you tuning in live on YouTube, as well as in the Zoom call, and want to thank Andrew again for a very enlightening talk.
Thanks so much, everyone.
Thank you.